This video provides some clarification on the force analysis homework problem. And so in this homework, you're given a solution for this problem with this linkage. And let me just switch over to here. So you have the manual solution all worked out on a PDF, and link 1 is just a grounded link, and here's link 2 that has some weight W2 and so on. This the coupler we just have as a rectangle and it has a weight also. So the free body diagrams are set up. If we just treat our free body diagram as link 2, link 3, and link 4, and then assume that the ground is where it's pinned to the ground, it could apply d sub x, d sub y, and c sub y and c sub x. The ground can apply that on this system and set up the equations. You can see we end up with 3 equations and 3 unknowns here. And so we have to do free body diagrams of some individual components as well. And we end up with 9 equations and 9 unknowns, which we can crank through and solve and come up with the required moment. Now, what I often see students do in a problem like this is to just pick up, they're trying to find the torque required to turn this arm. They just grab the weights and multiply times the perpendicular distance. So, W2 times A over 2 times cosine theta 2 and so on, W3 times this distance. And so that's what I have worked out here. If you tried to do the problem that way, then you end up with a moment of 4.4, which obviously is much different than 15.37. So what you now need to do is, for the homework, is do a case where you move this moment, instead of driving link 2, drive link 4. And then the second case is put the moment back on link 2, but now give link 4 a weight of 10 pounds. So that's all explained right here. So on Canvas, you already have the MathCAD solution worked out right here. So this is all set up. Just as a reminder, remember not to use this little subscript tool right here to put the subscripts in. Put in this case the capital D dot X. That it looks the same, but it doesn't work. It works differently. So, and the equations are set up, right? We have the known parameters, initial guesses for the unknowns, and because the moment has different dimensions, we did put in the units, the moment has different dimensions than the forces, you have to set up a vector like this first, and then you can output the answers. And just as a reminder, you can select tools and worksheet options and units. And so I based some custom units on US. I wanted the torque in inch pounds, so I had just selected insert. This is explained in some earlier videos on MathCAD. But so now you can see I just put in the torque to come out in inch pounds, because those are the units that I want the torque to come out in. So anyways, what you'll need to do is just modify the free body diagrams for these other 2 cases, but you'll really just have to make some minor changes to these equations. You can download this MathCAD file from Canvas and then just use it for your own calculations. So the other thing I just wanted to point out is you can model this in with SolidWorks and then run the simulation and generate. So you can put a motor on this link, for instance, and then generate this plot for the torque. And just one other thing I wanted to point out is if I open this part right here, right, I can select Tools and Mass Properties, and then I can go ahead and override the properties and put in the actual weight that I want, and it will be located at the center of mass. So we'll pick up from here on the next video.